Hello, I'm Kyle Mikowski, and this is Security Week. I'm with Team 28, along with Haran Wang and Rasim Badsi. This is a brief overview of what this presentation will include. We'll go over our project planning phase, where we'll discuss our opportunities that we came up with throughout the process and narrowed it down to our final product, a secure wake. We'll go over our customer profile that we developed for our person that we expect to buy this and use. And we'll go over the use case for that customer that we developed a profile for, discuss them. In addition to project planning, we'll go over our current progress and how well we're doing in the project so far, along with the project management and how we delegated each of our roles. And then we'll go over the identification of customer needs based off of surveys and interviews we've conducted throughout the process. And we establish target specifications too from those needs and determine which ones are the most important. And then we'll go over the economy, revenue, cost, and profit to see where we would achieve maximum profit and if this project is even profitable to begin with. So in the beginning, our opportunities were around a dozen or so, ranging from a variant of the standard alarm clock to something that people on their smartphones would have to alert them if something were to happen around them, like a danger, like a car coming and they weren't paying attention. But in the end, we narrowed it down to two products ideas: an alarm clock that either runs away from you, similar to Clocky, as seen here, developed by a Japanese company, or a programmable alarm clock module that you could add different parts to wake you up, like a hand that slapped you, or like a water pump, or something similar to that, like a feather that tickles you. But in the end, we went with an alarm clock that runs away from you, sort of, but with a variant on it. Unlike Clocky here, which has snooze buttons, ours has a number pad that you could use to input a code to turn it off, and nothing else. So, to identify our customer needs, we conducted surveys and interviews with multiple different customers from Virginia Tech and the outlying area, who were all college-age students, to see what they would like in a product like this. Some of the most important feedback we got was the ability to receive input, having the product lightweight, and having the display that's easy to read, so they could actually see what time it is, to know if they overslept or not, and if the alarm clock is actually working. And from those customer needs, we created a customer profile. Our first profile is college students that are engineers, specifically sophomores, who are most likely living off campus and own things similar to iPhones, iPods, a car, a computer, but they don't own stuff like a laptop, a high-end laptop, hardcore gaming one, an iPad, any technology that's older than 5 years old, or anything old in their minds. They like to have the newest, most advanced product. Meanwhile, our secondary customer profile were teens who are very similar to college students, where they both cared about school, but also had fun on the weekends and whenever they had free time, along with they don't like being late to class. But one of the main differences between teens and college students, aside from age and what they do, is the amount of money they have, because teens tend to have less money than college students, even though college students are in debt, because the teens normally don't have jobs because they aren't as free, technically speaking, compared to college students. But the customer profile is very similar, yet they have some differences. And our use case generated for these customers would be, the primary one would be, it's an ordinary Monday morning, secure wake goes off, runs around, and the user wakes up, has to catch secure wake, has to input their code correctly, and it turns off. But there's another flow where the user wakes up, they chase the alarm clock, but they're not paying attention or they're asleep partially still, so they input the code incorrectly. So the alarm is going off even louder now, and they have to input the code again correctly by waking up more to turn it off, which helps them wake up in the long run. And here would be the most opportune flow where they wake up successfully. This would be the secondary flow where they essentially press the snooze button by inputting the incorrect code, which sets the alarm off even louder. And here we have our Gantt chart, which displays our progress and what we've completed so far in the project. And as you can see, our current progress is designated by this solid line, and we're currently in the product architecture stage where we're working on actual designs and coming up with a physical build of the model itself to ensure that it's feasible and it can work. And we have multiple parallel tasks here where they can occur simultaneously but don't necessarily depend on each other, like the intellectual property search and the economic analysis, because economic analysis occurs throughout the whole thing and they don't rely on anything else. Same with intellectual properties, it only occurs for a short amount of time and it doesn't depend on other factors. And we're on schedule to end at our end date of December 5th for VTEPs. So our target specifications now, we came up with a few key specifications that we needed to focus on, and they were the ability to display time, having it easy to use, having a small size, and having a user-defined code that can be inputted to allow the secure wake to be turned off and disabled. And in the QFD diagram we have here, we have the needs with each other. 5 is the strongest correlation and most important. And then we move to technical importance, technical difficulty, where technical difficulty had a lower number be more difficult and harder to obtain. So we narrowed it down and created one which aspects would be the most important, as you can see here in this bar graph. And then through the technical difficulty section, we then defined what products, what aspects of the product would be more difficult to achieve and should require less focus on, so we don't waste time trying to get that, but we have more important aspects to work on. So we decided that the most important aspects that we have to focus on are a small size keypad, so it doesn't take up the whole clock, a display so that way they can see the time when it goes off, and aesthetics to the clock itself, because many of the customers said if it was not pleasing to the eye, they would not want to purchase it, which would result in the loss of revenue for the company. Now, here we have our economic analysis for our most ideal condition, where we started at $35 for a unit price and 7,500 sales. But every time we increase the price by $1, the unit sales per year decreased by 250. So we found that our maximum profit was achieved here at $48 per unit. And that led us to our next economic analysis, as seen here, where we found that the maximum acceptable unit cost was $47, as seen here. Because if any less or any more, it would not be feasible for us to do with the components given and the costs. And in conclusion, we developed customer needs around interviews and surveys that we conducted, and from those needs, we developed specifications that the product has to have in order for people to purchase it. And from those specifications, we created a QFD diagram that allowed us to determine what needs were the most important for us to focus on and spend the most time on to ensure that the product was successful and profitable, which led to our economic analysis, creating the maximum profit at $48 per unit. And then we also found out from our economic analysis how much we could have each unit cost before we start to lose money, and now it's going to be $47. We also found that we're on schedule for the project and that everything is going according to plan right now, and we're expected to meet our estimated completion time of December 12th. Are there any questions?